In these examples, we're going to learn how to use factor trees to find the prime factorization of a number. Find the prime factorizations for the given numbers using factor trees. Write the final result in exponential form and factored form. So we're first going to use a factor tree to find the prime factorization, and then we're going to learn how to write it in these two different ways. So here's what we want to do. Start with a given number and try to think of any factor of the number you can think of. Okay? So I see this as 12, so I can think of 2 and 6 or 3 and 4. It actually doesn't matter which factor you start with. If you're stuck on a factor, a good thing to look for is the number even. If it's even, you can use 2. So I'm going to use 2, and 12 is 2 times 6. Okay? So I'm writing 2 times 6, this will give me 12. Okay? Now when you get to a prime number, which 2 is, you're going to circle it, because we know prime factors can't be factored any further except for 1 in themselves. So we're going to stop at prime numbers. Now let's factor 6 further. Well, 6 is even, and it equals 2 times 3. And both 2 and 3 are prime, so I'm going to circle them. So I've actually finished this factor tree. You start with your main number, and you keep factoring until all of the branches have primes that are circled. So now let's write this in exponential form and factored form. We'll actually start with factored form. That means 12 equals 2 times 2 times 3. So you need to write 12 as the product of all the prime number factors you found. So notice, I'll highlight them here. You want to be careful. Sometimes when your trees get larger, you may lose a factor along the way. But here's our 2, 2, 3. And now exponential form, well, we learned that this is 2 factors of 2, which can be written as 2 squared. The factor 2, there's 2 factors, so there's also a 2 here. So this is our exponential form. Let's try the next one, 75. So the first thing I notice is that 75 ends in a 5. So I'm going to use 5 as one of the factors. You could also use 25 times 3. Now I'm just going to check. When I divide 75 by 5, the result is 15. So I need to write 5 and 15. These are 2 factors of 75, 5 times 15, that equal 75. Well, 5 is prime, so I'm going to circle it. 15 is not, so I need to factor this further. And I know that 15 is 3 times 5. So I'm just using the factors I can think of, and if you can't think of factors, you could do some factor tests like we learned in the previous videos. Both 3 and 5 are prime, so now these are all prime, and that means my factor tree is completed. So now I'll write it in factored form. 75 equals, I'm going to put the orders in increasing order, so 3 times 5 times 5. So 75 is 3 times 5 times 5, and in exponential form, this is 3 times 2 factors of 5 is 5 squared. So notice, now that we've done this factor tree process and we look at this, this is 75's prime factorization, 3 times 5 times 5, because all of these are prime numbers. And except for order, how you may have written them down, in the end, no matter how you start your tree or process your tree along the way, what factors you choose, as long as the numbers are correct, you're going to end up with the same result, the same prime factorization. So there's only one way to factor 75 into primes, and this is it. Let's try the next two problems. 63. So the first number I think of when I see 63, that's a factor, is 9 and 7. And that's from the multiplication tables. Okay? And if you didn't know that, you could always try dividing. So for example, you could try dividing 63 by 3, and you would get 3 times 21, and you could start your tree that way. So whatever numbers you think of are fine. 9 is not prime, but 7 is, so I'm going to circle 7. 9 can be factored further as 3 times 3. And 3 is prime, so I'm going to circle these. So here are my 3 factors. So my prime factorization in factored form is 63 equals 3 times 3 times 7. If I write it in exponential form, that's 2 factors of 3, which we write as 3 squared, times 7. So this is our prime factorization for 63. Let's look at the last one. So this number is a lot bigger than the numbers we've been looking at, and that may seem a little intimidating. But don't worry, because notice, as soon as you find a factor, the numbers start becoming smaller, and it's easier to think of factors of smaller numbers because we're more familiar with them. So I'm noticing right away that this is divisible by 5 because it ends in a 5. I don't know the other factor that corresponds to 5, the factor pair, off the top of my head, but I'm going to go to the calculator, divide 945 by 5, and I get 189. So we have 5 times 189. Well, 5 is prime, so I'm going to circle it. 189. So it's not even, it doesn't end in a 5, so it's not divisible by 5. So this one's a little bit harder to factor. But I'm just going to start with my prime factors, those first few prime factors. So 2 and 5 aren't going to work. We could try 3, we could try 7. Let's see what happens. So 189, is it divisible by 3? And it actually is. So that's nice. We can write this as 3 times 63. I'll circle the 3 because it's prime. And notice we have 63 here. That was actually our last problem. That's a coincidence. But we can start factoring 63. Let's do it in a different way than the last time. So 63 we found before, it's divisible by 3, so we could write it as 3 times 21. 3 is prime, 21 is not. 21 is 3 times 7, and both of those numbers are prime. So notice all of our branches are circled, meaning that we got all prime numbers. So our factor tree is complete. I just want to look, notice 63, from this branch downward we have 3, 3, 7, and that was our result over here. Even though we did it differently, remember you'll always get the same factors in the end. So now let's write. First we'll highlight our factors, and again it's really easy to miss one of these, especially if your tree is big, so you want to make sure you see all of your factors. Right over here, 945 equals, and I'm going to write the factors in order. There are 1, 2, 3 factors of 3, so 3 times 3 times 3, 1 factor of 5, and then 1 factor of 7. In exponential form, since there are 3 factors of 3, I can write that as 3 to the 3rd power times 5 times 7. And not all prime factorizations will have one that has an exponent greater than 1. Just all of these happen to.